IPSLA is one of those challenging areas to configure. It's challenging because it's got a lot of places where you can stumble into and go, whoa, that's not really the option that I want to configure. It's very full featured, and sometimes all of those features make you less sure of yourself when you're configuring it. Context sensitive help can really scare you. But let me show you how to configure this. So I want you to have the basic building blocks of this. You first start off with what is called the probe. And this was my first car, the Ford probe, but I want you to think more like a Star Trek probe, a probe that they're launching out into some astral body, checking for the existence of artificial intelligence or life or some spectacular thing. Here, we're checking the network. We're basically setting up parameters of what we're sending across. It's going to be ICMP echo. This is really the thing you're going to do, ICMP echo. And then you're going to set up the schedule. And this is what you want to do. IPSLA monitor schedule number, life forever, start time now. Remember that. Life forever, start time now. And I say that because if you use context-sensitive help, you'll start to get into timestamps and things like that, and you're just like, no. If we're tracking availability, which is the first thing you're going to do with IPSLA, it's going to be like this. So let me show you that, okay? So let me back out here, do exit, and I'm going to do IPSLA, and then we choose an entry number, but this is the ID of our probe. It's the ID of our probe. Do that, and then we say what we want to mimic. We want to not really mimic traffic. Let's just send an ICMP echo to an IP address that's relevant to us. 10.180.3, let's say .4. Then we get a little bit deeper, and here's where we can control. The only thing I'd control here is frequency. I just control frequency. Let's get out of there. And then I want to set up the schedule. So I want to reference my probe number, and then life forever, start time now. That's a lot easier, right? It's a lot easier to do it that way. So now I, in fact, have this thing, this traffic that is being generated. What I can do then is I can build an object, I can build an object that is tracking the probe. I'm setting up something that's looking at that probe as it is going out. We call that the object. So track 1, that's the object identifier, and then we reference IPSLA 11, which is referencing the ID above, and then we're watching for reachability. Reachability will be lost if a single ICMP echo is lost. It will be restored if we get a single successful reply back. Now, what can we do with this? We can modify the priority of our HSRB groups. Things like that are a basic building block to our distribution layer. We run these things called first hop redundancy protocols, HSRP, VRP, GLBP. And what they can do is they can track objects. They can all track objects. Some of them can track interfaces also. But what we can do is we can watch for connectivity downstream, and we can say, you know what? I don't want to be the forwarder for this group anymore because my reachability is not perfect anymore. I've lost one of my connections may be to the core layer. And if I lose one of my connections to the core layer, I'm no longer capable of sending as much data through. So what I'll do is I'll say, you know what, I'm not quite as good enough. I'll still participate in the group, but you should know that I'm not as good. And we do that by decrementing our priority by a value if the reachability goes down. If the reachability is offline, then I would decrement my priority in HSRP by this value. So I don't want to give you a full discussion of HSRP. We're talking about IP-SLA right now. But this is the kind of thing that you can do. And if you're thinking about router context for IP-SLA, you can track static routes. You can modify the administrative distance. Or, you can actually say the static route is only going to be there if the IP-SLA is good. Let me show you that also, just so you get a sense of it. I'll build this object. So track 1 IP-SLA 11, that's our object, then reachability. Okay. And then we just get out of that, by the way. So some of these commands actually do something but also navigate, which is a little confusing. But I just want you to see that if I build an IP route statement even, let's say I have a primary and secondary ISP, I can track this number and I can say, you know what? I don't want that to be inside of my routing table if the reachability is gone on this one. I'm not going to press enter there because that's just a syntax example. But you can start to see the power of IP-SLA, and hopefully you make use of that power in a responsible way.